Hey guys, this is Coach Lowe, and we're going to talk about angle measure. So grab your notebook, grab your Chromebook, and then open your notebook, and let's get these notes down. All right, so angle measure, let's talk about some terminology first. So I'll go ahead and have you draw two rays, and they're going to meet at a point. So remember, a ray has a starting point and then an arrowhead. So let's draw two of those and let's have them meet at their initial point here. So I have two rays that form an angle, and it's the union of those two rays that actually form that angle. So this is called the vertex, where those rays are meeting, or they're starting at the same spot. So I have a ray here and a ray here. Those are also called the sides of the angle. All right, we also have the interior. So if I have you put a point on the interior of the angle, that would be on the inside. And a lot of times you'll see this drawn where they're talking about this angle, or I'll make a line like that too if I'm talking about this angle. This would be a point on the exterior or outside of the angle, and then a point on the angle would be on one of the rays. All right, and this is my angle where I drew that line. So we've talked about that. The union of those two rays is my angle. Now let's talk about different types of angles. We have right angles, obtuse angles, and acute angles. If you know what those are, then go ahead and sketch those three and label them for me. Go ahead and pause the video and do that, and then come back and we'll check. Okay, now that you're back, it doesn't really matter where you've drawn these angles. Maybe you started on a new page, maybe you just wrote it over to the side. It really does not matter at all. So let's draw them here. So I have a right angle, and a right angle can make an L, and it does not have to be drawn this way. You could have drawn it like this at an angle. That's totally fine. But we want this to be a right angle, and we usually label that with a box in that angle corner, or toward the vertex. And so these are right angles. Right angles measure how much? Yeah, 90 degrees. So both of these would measure 90 degrees. Those are right angles. Now in geometry, you're going to hear me say this a lot. Don't go by what something looks like, unless they say pick out which figure appears to be whatever, whatever. Don't assume that that's what it is just by eyeballing it. We want to locate this piece right here. That is the signal that this is a right angle. All right, what about an acute angle? Oh, it's so cute. Little, right? That's what you say to little babies or little puppy dogs or little kitty cats. Oh, so cute. All right, so that's what that means. Just remember, acute angle measures less than 90 degrees. So this measure is less than 90 degrees. So think about it. You could superimpose a 90-degree angle on top of this and see that this red angle would be less than 90 degrees. So an acute angle. We can still label the vertex here, sides, all that good stuff. Okay, what about an obtuse angle? Obtuse. Just saying it like that makes it seem huge, doesn't it? So that's right. It's an angle that measures larger than 90 degrees. So let's go ahead and draw one of those on here. So you can kind of think about, okay, if I superimpose a right angle on top of this one, there's my right angle, and you can see that this is bigger than 90 degrees. I thought maybe I was through with this, but obviously not. All right, so now we have our three types of angles: right angles, acute angles, and obtuse angles. Right angles measure 90 degrees, acute less than 90, obtuse more than 90. Okay, so now on your screen you should be able to see this protractor, and we use a protractor to measure angles. And so let me just go ahead and get an angle drawn over here. So I see my vertex, and this is where I'm going to line up this part right here. I'm going to line that up with my protractor, and I'll go ahead and move this over. And let's go ahead and line this guy up. Let's see if I can get him to move. There he goes. All right, so we want this baseline. You can see the purple one and the yellow one. We want that baseline lined up, and it could go either direction, but since we're going out to the right, we'll line it up on the right. And then I want to notice here that I'm going to, I did not mean to move you. I'm going to start this guy looking toward 0 here. So I'm going to measure going this direction on this numbering part right here. So I'm coming all the way out here to 120, and that looks about right on where my angle measure is. So I have here, and then it goes out to 120. So about 120, maybe 21 degrees, 22 degrees out there. So we have some of these in the classroom that you can use to also be able to measure angles. All right, if the baseline of your angle goes out to the left side, then we would use this top piece to measure because it would be out on the left. Let me move it over here where you can see it a little bit better. So if I'm measuring and my line comes this direction instead, then I'm going to measure here with this numbering. So wherever it goes, you're going to start at 0 there. All right, a couple more things when we name angles. Angles can be named single letter, like let's say this is angle B, so we can name it angle B. You can also name it with 3 letters. Those are your only 2 options though. Angle ABC, and the vertex is always in the middle. So if they tell you to draw angle RST and it's an acute angle, you know that you need an angle that is less than 90 degrees because it's acute, and that S is going to be in the middle. So you could draw any acute angle, and as long as S is in the middle, it doesn't really matter where these other letters are, where R and T are. You can switch those around. Would be totally fine, but S is in the middle because it is the vertex. All right, angle bisector is the next thing I want to talk to you about. An angle bisector would be a line, a segment, or a segment that would come through my angle and bisect it. So what does bisect mean? Well, bisect means it's going to cut it into 2 equal pieces. So this angle would be congruent to this angle. And a lot of times we'll mark congruent with either the little arc or an arc with a line through it. And so I'm going to go ahead and put a point S here. So now I have 2 angles that are congruent. Angle ABS. So the measure of angle ABS is equal to the measure of angle SBC. Now I said congruent, and if we want to talk about congruent, then we move to taking the measure off and we say angle ABS, not ABC. Angle ABS is congruent to angle SBC. So notice, starting here, and the vertex is in the middle for both of those. The vertex is where those 2 angles meet. I also see, and we'll talk about this a little bit more, but ABS and SBC together make angle ABC. All right, that's all I have for you. I'll have a little activity where you get to match some things up, but that's it for your notes. So this is Coach Lowe, and I'm out.